Hi, I'm going to be taking you SolidWorks tutorials. But before I start with tutorials of SolidWorks, I have to introduce you to some machine design aspects because my SolidWorks design will be based on designing of machine parts, and the assembling of machine parts and detailing of the designs. So, topic, as you can see, getting started with machine design. So machine design can be classified into the following. Let's see. We have adaptive design, we have development design, we have new design. Let's check the three classes one after the other. We have adaptive design. This design requires no new knowledge of the existing design. That's according to definition. That is, let me explain. It has been in the system before, the design. So you don't need new knowledge. You just need new little manipulation of the design so that it can be adaptive to some condition, maybe environmental condition or anything. So the design work on adaptation of existing design. So the designer, we engineers, we make little alteration in the existing design. So let's go to the next class of design, which is what? Development design. This one requires some scientific knowledge to the design. This type of design modify existing design into a new design. So this one, as said by the definition, it just require modification of design that we have before, existing one. You have to modify it to your own taste, like to what you want. So the project may start from existing design, but the final results will be they will be different from the existing one. So the next one is what? New design. This is a very complex design. New design is a very complex design. This design is a good research and good technical ability and critical thinking. Because before you can venture into a new design, you have to make some research, like very, very good and thorough research. Make some findings, study journals, some books, textbooks to guide you for your design. You make research, experiment, you perform experiments. So new design is just invention. You invent new thing. So method used in design. That is, when you want to design, there are some method you use. So we have rational design, empirical design, industrial design, optimum design, system design, element design, and card design. So let's discuss rational design. Depends on mathematical calculation and mechanics of machine. This aspect, you divine your times, you do your mathematical analysis and machine mechanics of machine analysis too. Some stress analysis to your design so that it can be perfect and so that it cannot fail. So that the output you want and the efficiency you want can be met. That's the mathematical design. That's what they teach us in school. All the work that I've been doing in school, they are mathematical calculation, mechanics calculation, they have stress calculation that we do in school as an engineer. So the next one is empirical design. This one is based on what? Practical and experiment. These are lab works. After you've discovered some things with your mathematical calculation, or even without your mathematical calculation, go to the lab, perform some experiments, like maybe some strength analysis. We have experimental setup that can be used to determine the hardness of a metal, of a material. Tensile stress can be calculated using your experimental process. So that's empirical design. So let's go to next one. Industrial design. It is based on production aspects to manufacture machine. Let's say you've done some calculation, which is mathematical calculation, let's say maintenance of machine calculation, other aspect of calculation and that the design requires, you've done it. So maybe it requires experimental analysis, you've done that too. And you are now able to produce a 3D design or a 2D design. Then you take it to the what? To the industry. I mean to the workshop where it can be what? It can be produced, it can be manufactured before you assemble your parts. That's what the industrial design aspect. Optimum design, that is, it is the best design for a given object, function, order, specific constraint. That's the best solution a design can have. So let's go to the next one. System design. System design is of complex mechanical system. So every design we'll be working on will be what? Complex design, which is also a system design. I said that because it is possible to have a design of one part, but majorly we always have a design of several parts. In a situation whereby we assemble several parts, a system is being formed. So when we have a part that perform a function, another part that does another function, and assemble them together, and it gives us a unit. The unit we arrived at is what we can call the system. So we'll be working on several systems design as time goes on in our SolidWorks tutorial. So computer-aided design, that's the last aspect I'm going to go into. Computer-aided design, it is the SolidWorks that I want to teach you guys. Computer-aided design, you visualize your ideas. You will see what you are going to, what your outcome will be in your computer-aided design. You can stimulate to check if it will fail. If at all it's going to fail, the failure will be, if it's small, it will be something you can easily correct with little calculation or little adjustments after the design. But you'll be able to visualize your design, like see everything, majorly everything before you what? Before you manufacture your product. So that will be the end of this class, which I take as introduction class. So next lecture will be the beginning of the SolidWorks.